Hello everyone, the name of our project is Smart Systems for Occupancy and Building Energy Control. The team members for this project are Dalaris Hidalgo and Maria Presa, and the product owners are Ali Mustafavi and Leonardo Bobadilla. This video will serve as an introductory video to our application. Buildings are the #1 energy consumers in the United States. Everyone knows that saving energy is a good thing, but most people will only be motivated when you can demonstrate just how much energy they are wasting and just how much potential there is for them to improve. The goal of our project is to teach people how to save energy because simple changes in people behavior can quickly lead to significant energy saving. As part of our project management, we have a Gantt chart that displays how we divided the project for these past few months. We worked for a total of 5 sprints, each of which has been 2 weeks long. In our project, we have implemented various user stories, but in this video we will focus more on 2 user stories. View lighting statistics done by Maria Presa and predict a zone more likely to waste energy done by Dalaris Hidalgo. The first user story is a functionality that lets the user observe the lighting per energy performance of a specific room. The second user story is a functionality that using machine learning lets the user predict the energy consumption of the air conditioning in a room by using the outside weather provided by the Open Weather database and inside temperature provided by the user. The sequence to view the statistics information for the lighting performance shows how the statistical calculation class accesses the database to get the information it needs, calculates the data, and displays it for the user. The sequence to predict a zone more likely to waste energy shows how the class naive base uses the data from the database as training data. For our system design, we use a model view controller and a client-server architecture. Our application uses a class named SyncAdapter to access the MySQL database in order to get the information on energy performance as well as information on the zones and the user. Our hardware and software requirements show how our MySQL database is being hosted in a Linux virtual machine. The application is installed in an Android phone and it can access the database through HTTP. This is the ER schema of our database. The zone lighting table serves to provide information on lighting energy performance of a zone useful for the statistics. And we also have testing AC prediction table which provides it with training data in order to test the prediction of energy usage by air conditioning. As part of our security, Android applications use advanced hardware and software and it is designed to be truly open. To guarantee protection, its platform offers an application environment called Sandbox that ensures the security of data, users, applications, the devices, and the network. Sandbox can isolate apps from each other and so they cannot tamper with each other. Two of the most important design patterns in our minimal class diagram are model view controller and adapter pattern. Using model view controller, we can separate our UI code from our controller code. Using adapter pattern helps us create dynamic lists, grid views, and expandable lists. Our state machine shows the different states an activity in our application goes through, such as running, paused, stopped, and destroyed. The main algorithm for lighting is that we first get the sum of the energy usage in one day for the specified zone, get the times a zone is empty. If the zone was empty and the lights were on, then we consider the energy used as wasted. The main algorithm for air conditioning prediction is we first use the algorithm naive base to predict AC consumption, get the outside temperature from the Open Weather database, and the inside temperature is provided by the user. Then we display the result as low, medium, or high. For our automated testing, we used Andrea Espresso. This is the script for testing the use case view statistics information for lighting. It logs in as a user Mandy and validates the pie charts in the lighting view exist. This is a script for testing the use case predict a zone more likely to waste energy. We test the results by trying on our various inputs. As part of the view statistics for lighting test case, one sunny day is to validate that the system correctly displays the pie chart for both lighting energy usage inside a sun and lighting energy usage in a building. One rainy day is that if the user's phone is not connected to the Wi-Fi, then it will not display the pie charts. As part of the predict a sun more likely to waste energy test case, one sunny day is test making a prediction of air conditioning energy consumption for a user. One rainy day is test making a prediction while not providing input data. This demo shows how the user can select a zone, tap the lighting button, and get the lighting statistics for that zone. Then we will show you how the user can tap the button Predict AC Consumption and input the desired number for the set point, tap Predict, and predict if the AC consumption is either low, medium, or high.